how to construct a parallelogram using the GeoGebra. If you don't have it, Chris, yours wouldn't load?
Nope.
Okay, so you could, we'll just kind of, maybe you could share with someone and we'll discover some properties. I would like you to try to download this program at home or at some time. I'll help you. So what you want to do, if you have the, if you go up to view or perspectives and you hit geometry, you'll get a screen that has a grid on it, and then you can turn on and off that grid with this thing over here, right? That and that turns it on and off. I don't know what this is. Oh, because I have my arrow tool. Anyway, so what you first want to do to construct a parallelogram is get your segment tool. And what I found out, if you go to regular basic geometry, then that segment tool automatically comes up and you can just click on it. See that right there? That's your segment tool. So I want to do a segment from there to there. Doesn't matter where. Okay? And then you want to put another segment going from, this is going to be one of your sides of your parallelogram. So we're going to go there to here. And now what you can do is, see this thing up here? I think this is the parallel line tool. So if you grab that and you put a point right there, and then I think if you click this, wait, oh, that's a point on a line. That's the wrong one. Where's the parallel line?
No, that was the right one.
It was?
I think you just clicked the segment.
Click on this segment. Oh, there we go. So it made a line that's parallel to that. Good. Now I want to get rid of this point.
Oops, I accidentally made a
So I chose this thing, which is parallel line tool. And you click on this point and this segment, and I'll make a parallel line. Good. Now, next thing you want to do, you want to make it parallel to this line, right? To this segment. So you can just click on this segment and then click on this point. Let's see if that works. Click on this point. Click on this. Oh, I think I have the arrow tool selected.
Yeah.
So go on this. Okay. So I'm going to click on this point and this segment. And there, it made a parallel line that's parallel to this and this. And then I'm going to take a point and put it right here. Okay. Now, what I'm going to do is I'm going to take segments, since these are lines, and I don't want lines, I want segments. These are already segments, right? I'm going to draw segments on top of those lines, one from here to here, and one from here to here. Okay? Well, because the points will light up, and since I'm using this tool, it will automatically snap to those points. Now I can go and I can click on this line here. Click on that line. Click on that line. Whoops, it won't let me. Click on this line. Put a highlighting. And go edit. It won't let me.
It deletes the whole thing.
Yeah.
Oh no.
Deleted the whole thing?
Yeah. It did on mine.
Well, let's go display it. We can fix it. View, edit, hide objects. So I hit that line.
Wait, where?
And let's see. For some reason, it's not letting me select this line. That's okay. So let's see. Why is it not letting me do that? There we go. Where's that on?
You can have both days
Something I did, it didn't construct right. So, main acid plus, go back. Sorry. Got it? So, class, what you should have discovered now is what's true about this angle and this angle.
They're the same.
They're the same. And what about this and this?
They're the same.
And what about this plus this? They're supplementary. Okay? So if you grab your conjecture sheet, if you grab your conjecture sheet, chapter 5, you gotta get all of the conjectures. Which I'll come back to that.
What's consecutive mean?
I don't know if it'll work. Yeah, you're controlling my screen.
Okay. And you go down here to C45, okay? Parallelogram opposite angles conjecture. The opposite angles of a parallelogram are blank. No opposite angles. Okay? Opposite angles, which are this one and this one, and this one and this one, they are what? Congruent. Okay? So that's what you write in there. Okay? Then, what's the next one say? It says the parallelogram consecutive angles, so that means the ones next to each other, so this plus this, or this plus this, or this plus this, are supplementary, okay? So in those spaces, here you write congruent, and there you write supplementary. They add up to 180 degrees, or they add up to 180. Opposite sides conjecture. So we're going to go back to your drawing, okay? And you can measure the sides pretty easily by going tools. There's an easier way. But if you go tools, where is it? Measurement tools, distance or length, okay? And you click on this to here, okay? And from here to here, what appears to be true about those two lengths? They appear to be the same. Even if I drag my parallelogram around, do those things stay the same? Yes, okay? Doesn't matter what size I make my parallelogram, but if I constructed it by the definition of a parallelogram, which is a four-sided figure with two sides parallel, then they're the same. Okay? See if that's true about the other two as well. So you can actually use this tool right here. Somehow that tool popped up on my menu, I'm not sure. And those appear to be the same as well. Alright? Got that? There. So going back to your conjectures, the opposite sides of a parallelogram are blank, congruent. Okay? So now we're going to go back to our diagram again. Alright? And we're going to do something to this. We're going to draw in the diagonals of this parallelogram. Okay? Watch, follow along here, and do what I'm doing. Make a segment from here to here, and then a segment from here to here. Okay? Does it appear that those diagonals are congruent?
No.
No, they don't look congruent, but there's something else that's true. So first what I'm going to do is take a point and put it at the intersection of those two things. See where it says intersect two objects?
Yeah.
I'm going to put a point right where those two things are intersecting. See how I did that? Okay? And now what I want to do is measure the distance from here to here, and then from here to here. And also from here to here, and from here to here. Okay? So I'm going to go from here to here, and that's 2.5. And then I'm going to measure from here to here, and that appears to also be, at least in my picture, Won't let me drag that.
2.5.
2.5. Will let me drag that? No. Drag this. Come here. Won't let me move that. But, and then you also want to measure from here to here, which is 3.14, and from here to here, which is, I can't see. 4.48. Oh, and from here to here, and that is those two are the same. Okay? And let's see what happens if I drag my picture around. Okay? They stay the same. Even if I flip it upside down and backwards, right? This piece is the same as this piece, and this piece is the same as this piece. Got it? So, going to my conjectures right here, you can fill in this last one. The diagonals of a parallelogram flank each other. What do you think does? Not just intersect, bisect each other. Okay? They cut each other in half. Okay? And all of these four properties, I know you're looking forward to this, but next week we'll prove that all those things are true. Okay? But that's all you're doing for now, except there's one more thing that has to do with vectors. Okay? So I'm just going to use my multi-board now. Okay? So a vector, do you guys know what a vector is?
It's the guy in Despicable Me.
It is?
Oh, yeah. Because it means
Okay. A vector is a quantity. I'm tired. Quantity. A quantity that has both magnitude and direction. Okay? So write those words in there. Magnitude. And in this class we're just kind of doing not a real quantitative analysis of vectors, but it's one that's more kind of on the surface. Magnitude and direction. I'll show you. Okay? So, for example, a vector, it looks like a ray, okay, like this. So this might be an example of a ray, but it's also an example of vector because it has a length and it has a direction. So a vector might indicate something like wind speed. So this plane travels 500 miles per hour, kind of north. What would you call that? What direction is that? Northeast. Okay? Northeast. Please don't be playing. You should be writing down notes. You should be paying attention. Okay? And so one plane, so you might have a vector problem. Anyone think of another thing that might represent a vector? Another real life situation where a vector might be represented? Okay? A road? No, a road is just a length. Really?
yeah, but it has a direction.
Yeah, it's a direction.
Yeah, there's a way of
Yeah, I guess so. It could have a magnitude and a direction because it could have a length.
What does magnitude mean?
Okay.
Yeah, I don't know what magnitude means.
Magnitude means a number associated with it, right? Like if a plane is going 500 miles an hour northeast, or a plane is going 400 miles an hour northeast, this one has a magnitude of 500. The plane going 400 would have a magnitude of 400. Okay? You can add vectors by adding them like this. So say I have a plane going 400 miles an hour northeast, and I have a wind blowing 50 miles an hour southwest. Okay, which way is southwest?
Like that way.
Okay, and you indicate, you kind of try to do it proportionally. So if this is 500 and this is 50, okay, 50 mph southwest, okay, it would kind of be going down that way. And the reason they're teaching it to you in this chapter is because the diagonals of a parallelogram formed by this vector would be and the reason they have this in this chapter is because the diagonal of this parallelogram is the did I start recording again? Yeah. The diagonal of this parallelogram is called the resultant vector. So the parallelogram formed by making another vector parallel to this and another vector parallel to this. Okay? If I were to draw in a diagonal, right, from here to here, this is the direction and magnitude of how my plane of my result of adding this vector plus this vector. You understand that? So if I were going 500 miles an hour this way, and the wind was blowing me 50 miles an hour this way, if I draw in this side of this parallelogram over here, and this side of this parallelogram here, this resultant vector is how fast I'm actually moving and how the direction in which I'm actually traveling. So if I estimated this, if this is 500, what do you think this would be about? 250?
450?
Maybe like 450 or something, and maybe just a few degrees from, a few degrees from the east or something like that, okay? So 450 miles an hour, a bit, you could just say like a bit north from east or something like that. Now when you get to trigonometry, you actually have to calculate the length of this thing and the angle that it makes right here, and you can calculate its actual magnitude and direction. Okay? This might be like the resultant of forces too. Say you have like, say for instance you were to have a box, okay? Here's a box, a hexagonal, a square box, a rectangular box. We'll get a new piece of paper, right? So here's a box. And someone's pulling on this box with a force of 60 pounds in this direction, okay? And another person is pulling straight up this way with a force of 100 pounds or something like that. You could add these two vectors to figure out which way that box would actually be going. So you would take like one which is longer than this one. So say this one is 100. Hold on. And you take this one going this way, which is 60. Okay? And then if I make a parallelogram right here, where this is 100 as well, and this is 60 going this way, the resultant of those two forces is that that box is going to move with this amount of force, whatever that length would be, in this direction. You see that? So that would be, yeah, that would probably be a better way to think about it. So it'll probably be moving with a force of maybe, I don't know, we'll learn with cosine, so you actually calculate this length. But maybe it'd be approximately like 110 pounds in this direction, whatever that direction is. See? So you can do with forces, with airplanes, and all that kind of stuff. Okay, so that's the end. Sorry. That makes sense? So that's your homework. And remember, you heard it here on the math channel. Bye.